I am back for number 11, which is on page 33. Which factor is 4 factorial times 3 factorial divisible by? Okay, what are they getting at here? Would have to be factors less than 4 and 3. Okay, I'm just going to do it. I'm sure I'm missing what they're trying to tell me here, but here's the easiest way I know to explain it. Do 4 factorial. That's 24. And 3 factorial. I'm doing that on the calculator. And then 24 times 6 is 144. And then we need to see if 144 is divisible by 5. It is not. The reason is that 144 divided by 5 is not an even number. Is 144 divisible by 7? If you didn't have a calculator, this would be quite a bit harder to do. That is not divisible. C is 8. I can already tell you this one won't be divisible. Oh, it is divisible. Excuse me. I would have missed that one. I was after D, which is not divisible, but I thought that said 12, and I had my eye on that one, but it is not the answer. I just about missed that one, and that was not on purpose. And then 144 divided by 15 is not going to work. But I said that about C, didn't I? It's 9.6. So the one that is divisible evenly is C. And when we get to the answer key, I'm going to put myself a big question mark there because I need to figure out what it is they're trying to tell me. This is not what they wanted us to do, but this is the way I would do it. But we do need to check that one out. All right, number 12. After adding a rhododendron, there were 600 more ways that Leon could line up the plants on his windowsill than before. How many plants does Leon have now? Oh boy. This is a factorial. But how do I think I'm going to approach this one with the answers again. And I still have the feeling that I'm missing something, but let's see. 5 factorial is 120, I think. Let me make sure of that. Yes. 6 factorial is 720. 7 factorial is 5040. 8 factorial is 40,320. And 9 factorial is big. 362,880. After adding a rhododendron, there were 600 more different ways that Leon could line up the plants on his windowsill than before. Those are subtraction words. So I'm going to look at the differences here. 700 minus 720 minus 120 is 600. I like that. 5040 minus 720 is way too big. 4320. These are going to be even bigger. If you kept going, I'm not going to because we don't need to. But these differences would keep getting bigger. The further that I go, the differences will get bigger. We already see our answer. If he now has more plants than he did before, how many does he have now is the question. The 5 factorial was the number he had before. Now he has this many. So we're looking at the now. And I like answer B on that one. Alrighty. I'm going to try to get number 13 right in here. If I can't, I'll just go on to the next page, but I think I can. Like the little engine that could. I think I can. If you think you can, you can. Maggie is building a web page for her business. The banner at the top of her page consists of a background color, the name of her business, and a photograph. There are 6 choices for the background color and 5 choices for the text color. What additional information do you need in order to determine the number of possible banners? So we have to figure out, how do I want to say, the factors, let's say it that way, that will go into Maggie's web page. What are the options, the variables that will go into her web page? And then we'll use the fundamental counting principle. So we need to know, let me read again, consists of a background color. And so we know the choices for background. There are 6 of them. 5 choices for text color, and that would be the name of her business. So I'm just going to call that text. So those would get multiplied. And then the other variable is the photograph. So that's the missing variable. That's the piece that I don't know. What are the options for the photo? So the missing information is something to do with the picture. A says the number of letters in the name of Maggie's business. Well, letters is not one of my variables. The number of photographs that Maggie can choose, that's one of my variables. The colors available for the background and text, we already know those. We have 6 and 5. So those are variables, but they're known variables. The size of the photograph, no additional information is needed. I'm going to go with B. We need to know the number of choices she has for the photo. The key here is choice. How many choices can she have on the photo? The size of the photo doesn't matter in this situation. So I like B for that one, as in Bravo. All right, let's go to number 14. And which equation is correct? 5 factorial times 2 factorial, be careful here, is 10 factorial. 5 factorial is 120. And 2 factorial is 2. It's tempting to think because 5 times 2 is 10, but it doesn't work that way. This is 240. So that is not the choice. 8 factorial minus 4 factorial is 2 factorial. 8 factorial is huge. 4 factorial is 24. 2 factorial is 2. Is that true? No. And I think I'm going to do it this way. Let me back up to the first one and let's put in 10 factorial there. Is huge. Way huge. Those are not equal. This is not equal. Okay, option C is going to be 6 factorial times 7 factorial, times plane 7, excuse me, is 7 factorial. So 6 factorial is 720 times 7. 7 factorial is 5040. So is 720 times 7 5040? Yes. I like that one. But let's check them all. D. 3 factorial plus 1 factorial equals 3 factorial. Well, I can look at that one and tell you that can't be. But let's see. 6 plus 1 factorial is 6. No, that is not a true statement. And then finally, E, we have 9 factorial equals 3 times 3 factorial. Don't get rattled because it's backwards. It's an equation, so it can be written either way. Once you get to algebra, you learn that that can happen all the time. 3 factorial is 6. 3 times 6 is 18, not that big number. So that is not a true statement. I like C as in Charlie on that one. Number 15. Consider the following tree diagram. And I'm not going to draw it, but I am going to write the fundamental counting principle for this one. The first column has 2 choices. I'm going to draw it. I have to. I'm sorry. I wish I had just taken a picture of it and exported it in. But I need to show you this as we go. All right, the fundamental counting principle would have 2 as the first factor. And then each of those 2 has 2. All right. I need to look at the book again to be sure I'm not just making up stuff. Now, my lines won't be exactly the same, but they're connected, right? So 2 in the first choice, 2 in the second choice. And be careful here, you don't count 1, 2, 3, 4, because these aren't hooked together. You only count the branches up here. So this one is hooked to 2 choices, and that's where this 2 is coming from. The first 2 is coming from this one and this one. So those 2, and then the blue lines. 2 times 2 is 4. That's where you're getting 1, 2, 3, 4. And then finally we have the last two. I need to hook these together and copy it. Bear with me just a second, please. Or if you're drawing it too, I'm sure that you are working with me. So let's copy this one and speed it up just a hair. There's that one. And then here's this one. And you'll see why I wanted to draw it. So each of these has 2 options. So let's go ahead and add on another 2 and multiply it. So we should have a total of 8 options here. And we do. If you count those last limbs, you will have 8 of them. Okay. Which situation fits this diagram? Could be represented by this diagram. A pizza parlor offers 2 kinds of crust and 10 different toppings. That would be 2 times 10, which is 20. On a salad bar, there are 6 kinds of vegetables and 8 kinds of dressing. That's 48 choices. A jewelry store offers silver or gold charm bracelets. That's 2 choices. And customers can choose 4 or 8 different charms. So that's 2 choices for offers silver or gold of metal. And then I'm going to go with 2 choices for the number of charms. That one's a little tricky. At a sandwich stand, customers can choose white or wheat bread, ham or turkey, and mustard or mayonnaise. That's looking like a winner. A souvenir shop offers long-sleeved and short-sleeved t-shirts in black or white with 4 different logo choices. So the one that fits this particular tree, this particular picture, is D. And I'm going to go back and fill it in. This is why I wanted to draw it. So on D, we have white or wheat. That'll be the first choice you have to make. Then ham or turkey. So you can get white with ham or white with turkey, or wheat with ham and wheat with turkey. And then finally, you choose mustard or mayo. And I'm going to abbreviate here. And so this is mapping out all of the choices you have, if those are all the choices you have. In other words, you can't get chicken salad or tuna or chicken. You have to stick with the choices you're given. And so I like D for that one. But I am going to check these. This is page 33 in the back of the book. All right, starting with number 11. Oh, this is the one I had the question mark on. So number 11 is C. So we got it right. But let me look at their answer. The product is divisible by any product of factors less than 4 and 3. Okay, that's true. The number 8 equals 4 times 2. Okay, I like the way we did it better. C is the answer, as in Charlie. Number 12 is B as in Bravo. We got that one right. Number 13 is B as in Bravo. We got that one right. Number 14 is C as in Charlie. And number 15 is D as in Delta. So I like all of those. And I'm going to stop this video and I will see you back for the next one.